Your PC can go from off to the login screen in just a few seconds, but inside those few seconds, a lot has to go right. The power supply has to wake up, the motherboard has to respond, the CPU needs instructions, RAM has to be checked, storage has to be found, and only after all that does Windows get its turn. So when you press the power button, you are not directly powering every part of the PC. You are only sending a small signal to the motherboard. Okay, start the sequence. And the first real question is simple. Can the power supply deliver clean, stable power? After the motherboard receives the power on signal, it tells the power supply unit, or PSU, to wake up. The PSU takes electricity from the wall and converts it into the different power levels your PC parts can safely use. Your motherboard, CPU, GPU, storage drives, fans, and everything else depend on that power being stable. If the PSU cannot provide stable power, the boot process may stop before the computer even gets a chance to do anything smart. That is why a PC can sometimes flash, click, spin for 1 second, and then shut off again. It did not almost load Windows. Windows was not even invited yet. The system may have started the process, but the power did not pass the early safety check. Once stable power is available, the motherboard can begin bringing the rest of the system into the startup sequence. With stable power available, the motherboard becomes the main coordinator. It connects the CPU, RAM, GPU storage, USB devices, fans, and other parts into one working system. But at this point, the PC is still not loading Windows. The motherboard is only preparing the hardware so the first startup software can take control. If something important is missing or connected incorrectly, the process can stop here. A loose RAM stick, missing CPU power cable, or badly seated GPU can keep the system from moving forward. So if the lights turn on but nothing shows up, don't celebrate too early. The PC has power, yes, but power is not the same as a successful boot. Once the motherboard has enough basic hardware ready, it hands the early startup process to the firmware stored on the board. This firmware is called BIOS, or UEFI. BIOS is the older version. UEFI is the newer, more modern version. But for this explanation, they do the same basic job. They help the PC start before the operating system is ready. At this stage, Windows is still not running. No desktop, no apps, no dramatic loading screen. Yet. The firmware is checking the system, reading hardware information, and figuring out what should happen next. It looks at things like the CPU, memory, storage devices, and boot settings. This is also where you may see the motherboard logo appear on screen. That logo shows up before Windows because the PC is still being controlled by the firmware. Once the firmware has enough information to continue, it gives the system the first real instructions it needs to move forward. After the firmware takes control, the CPU begins running the first instructions. A CPU is powerful, but it does not wake up magically knowing what to do. It needs a starting point, at boot. That starting point comes from the firmware on the motherboard. The CPU is not opening apps yet. It is not loading your browser. It is not preparing your game library like it misses you. It is only doing the early work needed to prepare the machine. It follows the firmware's instructions, helps initialize hardware, and moves the system toward the next stage. If the CPU is missing, unsupported, damaged, or not getting proper power, the boot process can stop here. You might see fans spin, but the PC may never reach the point where it can show anything useful. Once the CPU can execute those first instructions properly, the system is ready to test whether the most important hardware is actually working. With the CPU running early instructions, the PC begins POST, which stands for Power On Self-Test. POST is the computer's first major self-check. Before it tries to load the operating system, it needs to confirm that the essential hardware is present and usable. It checks things like the CPU, RAM, GPU, and storage devices. Basically, the PC is asking, do I have the parts I need to actually start? If something critical fails, the PC may stop before Windows ever gets a chance to load. That is why motherboard beep codes, debug LEDs, or small error numbers can be useful. They are not random little panic lights. They are clues about where the startup process got stuck. A RAM light can point to memory trouble. A VGA light can point to graphics trouble. A boot light can point to a storage or boot device issue. So even if the fans turn on, the PC may not have successfully started yet. Power only means the process began. Once Post confirms that the basic hardware is usable, the system can prepare one of the most important parts of the boot process: memory. After Post confirms the basic hardware is usable, the system prepares the RAM. RAM matters because the PC needs temporary workspace before it can load anything bigger. The operating system, drivers, apps, and background processes all need memory to run. But before that happens, the motherboard and CPU need to make sure the RAM is detected and configured correctly. The system checks how much memory is installed, which slots are being used, and what speed or settings the memory should run at. On some PCs, especially after changing RAM or enabling XMP or Expo, this step can take longer because the system is training the memory. Yes, your PC may look like it is frozen. No, it is not always being dramatic. Sometimes it is just figuring out how to run the RAM properly. If the RAM fails here, the boot process can stop very early. The PC may turn on, but never reach the screen where Windows begins loading. Once the system has working memory ready, it can move toward the part most users notice first: getting an image onto the monitor. With memory prepared, the PC now needs a way to show you what is happening. That job belongs to the GPU. Either a dedicated graphics card or integrated graphics built into the CPU. Even before gaming, video editing, or 3D work, the PC still needs graphics hardware just to display the boot screen, BIOS menu, motherboard logo, and later, the operating system. The system checks which graphics device should be used and sends a video signal to the monitor. If this step fails, the PC may still be doing something in the background, but you will not see it. That is why a black screen does not always mean the entire computer is dead. Annoying, yes. Useful clue, also yes. The issue could be the GPU, the monitor cable, the wrong display port, or plugging the cable into the motherboard when the CPU has no integrated graphics. Once the PC can show an image, it can continue looking for the place where the operating system is stored. After the display path is ready, the firmware checks the storage devices connected to the system. This includes NVMe SSDs, SATA-SDs, hard drives, and sometimes USB drives. The PC needs to know what storage exists before it can find the operating system. But detecting a drive is not the same as booting from it. That part causes a lot of confusion. Your SSD can be detected perfectly, and the PC can still fail to start Windows. The firmware also needs to follow the boot order. That boot order tells the system which device to try first. If the wrong drive is first, or the main SSD is not detected, the PC may drop into BIOS instead of loading Windows. At this stage, the computer is basically asking one question: where is the system I am supposed to start? Once the correct boot drive is found, the firmware does not load the entire operating system by itself. It passes control to a smaller program on that drive. Once the correct boot drive is found, the firmware passes control to the bootloader. The bootloader is a small program stored on the drive. Its job is not to be the full operating system. Its job is to start the operating system. For Windows, this usually involves Windows Boot Manager. It helps the system find the files needed to begin loading Windows properly. So at this point, your PC is basically done asking, which drive should I use? Now it is asking, okay, how do I actually start Windows from here if the bootloader is missing or damaged? The SSD may still contain your files, but the PC may not know how to start from it. That is why some boot problems show messages like no boot device found, boot manager missing, or automatic repair. Very fun messages to see at 1 a.m., extremely calming. Obviously. Once the bootloader finds what it needs, it begins loading the core part of the operating system into memory. After the bootloader does its job, the operating system kernel begins to load. The kernel is the core of the operating system. It is not the desktop, it is not the start menu, it is not the taskbar. It is the deeper layer that manages the CPU, RAM, storage, devices, and system processes. At this point, Windows is finally starting to take control from the early boot system. The PC is no longer just checking hardware, now it is building the software environment that everything else will run on. The kernel also starts setting up the rules for how programs and hardware will communicate. Without it, your apps would not know how to use the CPU, access memory, store data, or talk to devices. Basically, this is the part where Windows stops being something on the drive and starts becoming the system that runs the machine. Once the kernel is running, the PC can start loading the extra pieces that make your specific hardware work correctly. With the kernel running, the operating system starts loading drivers and services. Drivers let Windows talk to your hardware properly. Your GPU, audio device, network adapter, chipset, storage controller, mouse, keyboard, and many other parts depend on drivers to work correctly. Without drivers, Windows may know that hardware exists, but not how to use it properly, which is not ideal. Services are background processes that support the system. Some handle security, some handle updates, some handle networking, audio, printing, cloud sync, or device management. This stage is one reason a PC can feel partly ready before it is fully ready. Windows may already be loading, but the system is still bringing many background pieces online. If a bad driver or broken service causes problems, the PC may freeze, restart, or get stuck during startup. Once enough drivers and services are running, the system can finally show the part most users recognize, the login screen. When you type your password or PIN, Windows still needs to load your user profile. That includes your desktop settings, personal folders, save preferences, and the apps assigned to your account. So reaching the login screen means the system is alive and ready for you to enter. But your personal desktop session has not fully loaded yet. Once you log in, the PC moves from system startup to your actual user environment. After you log in, Windows begins loading your desktop. This is the part that feels like the finish line. You see the wallpaper, taskbar, icons, and maybe a few apps opening automatically. But the PC may still be working behind the scenes. Startup apps can begin loading. Cloud sync tools may connect. Security software may scan. Game launchers, RGB software, audio tools, update services, and driver panels may all start in the background. Yes, RGB software needs its moment too, apparently. That is why a PC can show the desktop but still feel slow for a short time. The visible part is ready, but the hidden work is still catching up. This is also why two PCs with similar hardware can feel completely different after login. One may have a clean startup. The other may be trying to launch half the internet before you even move the mouse. Once the desktop settles, the boot process is basically complete. But if the PC fails before this point, the stage where it fails can tell you a lot. When a PC fails to boot, the most useful question is not just what is broken, it is where did the startup process stop? If nothing happens when you press the power button, the problem may be near the start of the chain, the power button cable, wall power, PSU, or motherboard. If fans spin but there is no display, the PC may have power but fail during post-RAM initialization, CPU startup, GPU initialization, or display output. If the PC enters BIOS but does not load Windows, the issue may be closer to storage, boot order, or the bootloader. If Windows begins loading but freezes, restarts, or takes forever, the problem may involve drivers, services, updates, corrupted system files, or background software. That is why understanding the boot process is useful. It turns a vague problem into a timeline. The PC is not just dead or working, it is moving through a chain of steps. And when one step fails, everything after it stops. If this breakdown was useful, give it a like, subscribe for more deep dive tech content, and turn on notifications so you don't miss the next video.